In this video, I will explain you a question based on transformations. So we have basically 4 types of single transformation, which enlargement, translation, rotation and reflection. Look at the first example. Triangle A is drawn on the grid. Transformation P is represented by the matrix -2, 0, 0, -2. P maps triangle A onto triangle B. Draw and label triangle B. So you can clearly see the transformation P is a matrix which is -2, 0, 0, -2. This matrix is used to map triangle A onto triangle B, and the triangle A is drawn on the grid. So the first thing is we write down the transformation matrix, which is -2, 0, 0, -2. And then let's write down the coordinates of triangle A in XY form, which is, this is 2, 1, 2, 1. Then we have here 2, 3. So 2, 3. And then you have here 3, 1. So we have here 3, 1. I wrote the coordinates of triangle A in X, Y form. Thereafter, I use matrix multiplication to find the coordinates of the triangle B. So you know how to multiply two matrices. Which is row by column form. So -2 into 2, it's -4, which is here. And then again -2 into +2 here, again it's -4, because 0 into 3 makes a 0. And -2 into 3, it's -6, plus 0 into 1, it's 0. So likewise, we use matrix multiplication to find the coordinates of the triangle B, which is -4, -2, -4, -6, and -6, -2. Nextly, they ask you to describe fully the single transformation P. Now we can see that in the previous part, we mapped triangle A onto triangle B by a matrix. Now they are asking you to describe the single transformation of this matrix P. So we can clearly see that the single transformation here is an enlargement, because the triangle A has enlarged its size on triangle B. And you can also see the triangle A has flipped its side. This is triangle A, it has flipped its side when it comes to triangle B. And you can clearly see the triangle B is twice the size of triangle A. So triangle A, we have only one square over here. We have 2 squares here. So I call that triangle B is twice the size of triangle A. Since it has flipped the size, it's a scale factor of -2. Not only that, you also have to find the center of the enlargement. How do you find the center of the enlargement? By joining the corresponding corners, the corresponding edges of the two triangles, and all the edges would pass through one particular point. So this is called as the center of the enlargement. This is called as the center of enlargement. And when you're writing the single transformation P, firstly you have to say that it's a negative enlargement with a scale factor -2, and the center of enlargement is 0, 0. Next part of this question is, write down the ratio area of triangle A to area of triangle B. In this case, we know that the length of one side divided by the other side. I'll call this as length 1 and length 2. Whole thing squared is equal to area 1 over area 2. Such it is 1 over 2 whole thing squared. Now from where do you get this 1 over 2? The length 1, I consider it as the length of A. This is 1 unit. And the length 2, it's 2 units. Length 2, it's 2 units. So length 1 over length 2 whole thing squared is equal to area 1 over area 2. So which is equal to 1 over 4. Which is equal to 1 over 4. So the relationship between triangle A to triangle B, of its length, it's 1 over 2. Of its area, 1 over 4. The continuation of the question, transformation Q is represented by the matrix 1, 0, 0, -1. Q maps triangle B onto triangle C. Draw and label triangle C. So this is similar to the previous part of the question. So the first thing is you have to write down the transformation matrix, which is Q, that 1, 0, 0, -1. You have to write the transformation matrix first. Then you write down the coordinates of triangle B. You use matrix multiplication, row by column method, and you will find the new coordinates of triangle C. So let's mark the points of triangle B map onto triangle C, the new triangle C. And in this case, they have not asked you what is the single transformation of this particular cube, but the single transformation of cube is, you can clearly see, it is a reflection along the x-axis. When you reflect triangle B onto triangle C, you know the reflection is the mirror image, no? So the reflection is the mirror image. Triangle B is reflected to triangle C. How? Along the x-axis. That is the single transformation of Q. But in this question part B, we have used Q as a matrix, which is 1, 0, 0, -1, to transform, to map triangle B onto triangle C. Part of this question is, the transformation Y is represented by the matrix 1, 0, 0, 3. Y maps triangle A onto triangle D. So we have to do the same thing again. First thing is you're writing down the transformation matrix, which is 1, 0, 0, 3. Then we have to write down the coordinates of triangle A, because A is mapped onto D, and we use the matrix multiplication, the row by column method, to find the new coordinates. That means to find the coordinates of the triangle D, which I have already marked on the diagram. Thereafter, they also ask from you if triangle D is mapped onto triangle A. What is the mapping matrix? What is the transformation matrix? So in this case, you can see when you map triangle A onto D, you use the matrix 1, 0, 0, 3. When you map A onto D, you used the matrix 1, 0, 0, 3 to map A onto D. Now in case if they ask from you, you have to map triangle D onto A. That means this big triangle, you are going to map it to A. At such a time, D onto A, we are using the inverse of the original matrix. So I assume that you know how to inverse a given 2 by 2 matrix. So when triangle D is mapped onto triangle A, given that triangle A mapped to triangle D by the matrix Y, which is 1, 0, 0, 3, D onto A is mapped using the inverse matrix. So I assume that you know how to inverse a matrix. Firstly, you take the determinant, which is 1 over 3. And then you change the positions and change the signs of the matrix. And the matrix which transforms triangle D onto A is the inverse of the original matrix.